we have a function of two variables, say for example, f of xy is y squared minus xy plus y cosine x, then by fixing one of the variables, we get a function of one variable. So for example, f of y 0 comma y is a function of one variable, y squared plus y, or f of x comma 1 is 1 minus x plus cosine x. So actually there's a couple of different ways of thinking about a function of multiple variables. One is, as we've been saying, a function takes in two numbers and spits out a number. But you could also think of it as a function which takes in one number and spits out another function. Functions R to R. So from the first point of view, you'd be writing f of xy. In the second point of view, you'd be writing f of x of y, or maybe f of x comma blank of y. So then these functions of one variable, we can take the derivative of. We could talk about d by dy here, or d by dx here. But we could also do that. We could then do that for every value of these fixed variables. So let me write this down. So if we hold all but one variable constant, so treat it as a constant, and then differentiate with respect to the last variable, respect to the remaining variable, we get what's called the partial derivative of this function with respect to that variable. So this is denoted either del f over del x, or maybe f sub x of xy. So this is pronounced, I think, del f over del x. So we use this backwards 6, which looks also kind of like a fancy cursive D, to emphasize that this is a partial derivative. And so this measures how f is changing in the x direction. So let me work through several examples of this. So let's start with exactly that example. F of xy is y squared minus xy plus y cos x. Then to find del f by del x, we'll treat y as a constant. So now y squared is also a constant, so that goes to 0. Then negative y is the coefficient of x, so we get negative y here. And then y is the coefficient in front of cosine of x, so this becomes negative y sine of x. Then for del f by del y, this will now be 2y, now minus x is the coefficient of y, and plus cosine x is the other coefficient of y. Here's another example. F of xy equals y sine of xy. Now del f by del x, so we've got a y inside the sign, so by the chain rule, we'll pull the y out, we get y squared cos xy. Then for del f by del y, now we have to use the product rule, so that'll be sine of xy, then plus y times the derivative of cos xy, so now that'll be an xy cos xy. So now we're pulling out the x as the coefficient. Okay, now here's a slightly uglier example. So we'll do negative x squared plus 3y squared over xy minus 10. So now del f by del x, we need to use the quotient rule. This will be something over xy minus 10 squared. So derivative of the top is negative 2x with respect to y, or with respect to x. Then that times the bottom, xy minus 10, then minus derivative of the bottom with respect to x is just y, and then that times the top, negative x squared plus 3y squared. And this is, multiplying this out, we get negative 2x squared y plus 20x plus x squared y minus 3y cubed. And so this becomes just negative x squared y plus 20x minus 3y cubed. Then for the partial with respect to y, this again will be something over xy minus 10 squared. Now derivative of the top is 6y times xy minus 10 minus x squared plus 3y squared, and then derivative of the bottom is x, and so then this is 6xy squared minus 60y plus x cubed minus 3xy squared, and so that becomes 3xy squared minus 60y plus x cubed. All right, finally, let's try f of xy is x over x squared plus sine of y plus 1.01. So I put this 0,1 here to make sure so that we don't divide by 0, since x squared is always greater than equal to 0, and sine of y is always greater than equal to negative 1. Okay, so del f by del x, we'll have to use the quotient rule again, so this will be something over x squared plus sine y plus 1.01 squared. And the same will be true for del f by del y, so let me just write that out now. X squared plus sine y plus 1.01 squared. Okay, now for del f by del x, derivative of top is so 1 times x squared plus sine y plus 1.01, and then minus x times derivative of the bottom will be 2x. So this becomes, that's 2x minus 2x squared. So this just becomes minus x squared plus sine y plus 1.01. Then for del f by del y, derivative of the top with respect to y is 0, and then minus x times derivative of the bottom with respect to y is cos y. So we get negative x cos y over that denominator.